Okay, so let's go ahead and discuss. So you guys were looking at the examples of what does make a function, and you're looking at the examples of what does not make a function. Let's see if we can come up with what creates a function, or what rules or characteristics will relate to functions. Let's first start with the Venn diagrams. So with these little Venn diagrams that we've got here, here are two examples of Venn diagrams that are functions. And just keep this in mind, that these are your x values, these are your y's, or this is your domain, and this is your range. Same thing for here. This is your x, which is your domain. This is your y's, which is your range. So taking a look at what they look like for a function versus down here. Here are two Venn diagrams. Again, x and y, and these are not functions. So who thinks they can raise their hand and tell me, what did you notice is different between the ones that were functions and the ones that were not? Bridget? Not a consistent rule. Okay. Anybody have anything else? Armando?
In the ones that are functions, like they're like in straight lines or diagonal, but then the ones that are not functions, it's like one number goes to two instead of just
Which number?
and five goes to the four instead.
And what do we call those values? These values are called what? Say it louder. The domain. So what he noticed is that up here, each one of those just goes to one value, right? Each one of the domains only branched out to one of the values. So they either created a straight line, or if they created a diagonal line, that's not a big deal. But each one of these domains, he says, only went out to one value, right? Versus here, not a function. Some of them, some of the domains, like the 5 branched out to two values. Or the same thing for over here. The 1 branched out to two values. That's different. Okay? Each one of these only goes off to a single value. Okay? So there's a characteristic. Your domain cannot go to more than one range. All right, let's take a look at the charts, or the graphs. Here's pictures of our graphs. Here's another graph. Those are functions. Versus here's some pictures that are not functions. What do you notice with the graphs, Alex?
That with the function graphs, it's the one line, with the other graph, it's the
Okay. Well, let me give you an example of another graph then. That's just one line. I'll do it in a different color. That's also not a function, but it's just one line. What do you think, Armando?
the functional ones have like curves, and the ones that are not function have like straight.
Well, these are straight and these are functions. So he said that, oh, the functions have curves and the non-functions are straight, but these also are straight and they are considered functions. This one might be a little bit hard, but it's kind of the same idea of, see how these x's can only go to one of the y's? It's the same thing for here. What makes it not a function is that at this point of x, I can hit a y up here and I can hit a y down here. At this point of x, I have all of these points of y's. Okay? At this point of x, I can hit the y value here and I can hit a y value here. But versus a function, at this point of x, I hit the y only one spot. I hit the y in only one spot. I hit the y in only one spot. I have to keep moving along my x's to where I can hit another y. Okay? Let's take a look at the ones that represent points. Here are values that are functions. These are functions. Here were the ones that were not functions. What do you notice for values that are versus values that are not? Alex, you want to try it again?
They're not, they're all, everything are all not following the same rule.
Not quite. Sometimes when we have an actual rule with a function, it might just be that it's a linear function, which we're going to discuss that later. Those are the ones that have patterned rules. Okay? These ones are not functions because if you notice here, look at the x value, the input or the domain. What do you see is happening inside the chart? Everybody take a look. Look at the x values inside of the domains. What do you see as something? Bridget? Some of them are repeating. Again, for this one, you've got a 1 and a 1 for your domain. For this one, you've got a 4 and a 4. If you look back up here with the functions, none of the x values are repeating. None of them repeat. So here's the rules that you need to make sure that you are following. Turn it on over. Rules to follow for functions. Rule number 1, the domain cannot repeat. The domain, which is known as your x, which is known as your input, cannot repeat. The domain cannot repeat. It cannot have more than one range value. Okay? So when we were looking back at the problem of our Venn diagrams, so I'm going to come back to this. When it was a function, the domain only branched out to a single range. Each of my domains only had a single line exiting it. Now, granted, if we look here at this one, the range repeated, didn't it? The range, this range of 16 has more than one domain, but as long as each domain only branches out to one value, that's all that matters. The domain is not allowed to repeat. Same thing for here. Looking at the x values, the x values do not repeat. Oops, this is supposed to say x, not y. The x values never repeat. The y can repeat. See, notice we have a y that repeats here and a y that repeats here, but the x value cannot repeat. That is important to know. When we look at the ones that were not functions, our domain had double lines branching out from it. Or in the graph, our domain had two of the same value repeating. You cannot have the domain repeating. But again, like I said, that is not to be mistaken with the range. The range can repeat. It doesn't always repeat, but it can. It is allowed to repeat. The domain is not allowed to repeat. That is a very big thing to make sure you keep in mind. The domain cannot have more than one range attached to it or connected to it. Now that's how you can tell from Venn diagrams. That's how you can tell from points that were given to you or a table that's given to you, how to easily identify it if it's given to you as a graph is you have to pass the vertical line test. The graphs must pass what we call a vertical line test. And I'll show you that in just a second. So what the vertical line test means is that when you draw a vertical line anywhere on the graph, it will only pass over the graph at one point. No matter where you draw a vertical line, it should only hit the graph function at one point. That's what it means to pass a vertical line test. If you draw a vertical line and it passes through more than one point on your graph, then that means it is not a function. Let me turn it over real quick to show you an example. So, locating right here, no matter where I draw a vertical line, I am only going to pass over it at one point. I can draw it anywhere on my graph that I want. I pass over it at exactly just one point on the function. Same thing for this one. No matter where I draw my vertical line, I am passing over it at just exactly one point. Same thing with these straight lines. Passing it over at just one point on the vertical line. Okay? Passing over it at just one point when I draw a vertical line anywhere that I want. Now, if I come down to what's not a function, here are the examples that are not functions. When I draw a vertical line, in this case, I'm passing the function at 2 points. Not allowed to happen. That makes it not a function. Same thing for over here. When I draw a vertical line right here, I'm passing it at all of these points that are on that line. If I come over to the circle and I draw a vertical line, I'm passing through the circle at 2 separate points. You are not allowed to draw a vertical line and hit the graph more than once. Okay? So if it doesn't pass the vertical line test, it is not a function. Let me go back over to what that rule is. Graphs must pass the vertical line test. It can only hit one point on the graph to be a function. So what I want you guys to do right now, with that information now in your minds, tell me whether graphs 1, 2, 3, or 4, whether those informations are functions or not. If they are not functions, I need you to tell me why. If it is not a function, tell me why. All right, problem number 1, we have the points 3, 7, 2, 6, negative 3, 8, 2, 4. Is that a function or not a function? Not a function. Why? Because the domain repeats which value of the domain? The 2. Okay, the 2 repeats. That 2 for the domain repeats. You do not want the domain to repeat. So it is not a function. Okay, come down here to number 2, looking at this Venn diagram. Is it a function or not a function? It is not a function. Why? Because it's not that it has more than one range, but that the negative 1 has more than one range. Not just in general it has more than one range, but the negative 1, one of your values in your domain, is branching off to 2 values. You do not want that to repeat. So that is not a function. Not a function. Okay, problem number 3, function or not? Function. This is a function because each one of these domains has exactly one line branching off from it. So this is going to be a function. And then problem number 4, function or not? Not a function. If we draw a vertical line, we actually do pass through these 3 points at the exact same location. Okay, so this is not a function. Any questions? Okay, on Google Classroom. You have two IXLs that you are going to be identifying whether they are functions or not. One of them focuses only on graphs, the other one focuses on data tables. Okay, go ahead and get started.